Thanks for coming back. Today we're learning dynamics inclined planes.
Hi, my name is Saran, and I will be teaching dynamics inclined planes. A block is sliding down an inclined plane with mass m. You know that gravity is always acting on an object in the downward position from the center of mass. Force weight, which is gravity, which is acceleration, which is negative 9.8 meters per second squared. Okay. Normal force is perpendicular to the inclined plane, which from the center of mass, which will always go that way. Sometimes friction is negligible, but majority of the time, friction is present on the object in motion. Friction is the force resisting relative motion. So if the block is sliding down this way, this is force applied. Friction is the opposite resisting force acting on the mass, meaning it will go the opposite direction. This is force friction. And force friction is measured in mu. Now, let's try an example.
Pause. Try it on your own now.
Okay, so let's start with our given. Mass is 26 kilograms and our theta is 22.6 degrees. We're trying to find acceleration, but first we have to calculate our force weight. Force weight equals mass times gravity. Plug in 26 kilograms times, you can round 9.8 to 10, and you'll get 260 newtons for force weight. Now, we have to find both y and x components of the inclined plane. So you will be using sine and cosine. Sine is in the y direction. So it will be F equals FG sine theta. You plug in your given. 260 times sine times 22.6 degrees, and you'll get 100 newtons. To find your cosine in the x direction, you'll do force normal equals force weight equals force weight cosine theta. Plug in your given. Cosine theta of 22.6, and you get 240 newtons. Well, we're trying to find acceleration, so we'll go back to the basics of force equals mass times acceleration. But since we're trying to find acceleration, divide mass on both sides. So A equals force divided by mass. Plug in your given. 100 over 26. And your acceleration is 3.8 meters per second squared.